Alright, hello, welcome to this demo of microservices with Go. Basically, I'm going to showcase this microservice architecture application and how all the backend services basically communicate with each other. So there's obviously going to be some REST, a little bit of gRPC, and yeah, that's the whole premise of this video. So let's get on to it. First off, what I'm going to do is pull up my editor. So these are all the services right here, the back end, front end, whatever. What I'm going to start with is just run my front end, which is this web page. So let me refresh it. It will get stuck because it's not running. So I'm going to do go run cmd web. All right. And I'm going to have to redo this. All right. So I've got my front end service running. And now if I do any of these things, it will not work because the backend services are not running. So what I want to explain here is like these are all different services. As you can see, like front end is running while the others are not running. So they are independent of each other. And what I mean by that is like they are all their own standalone applications. So they can run independently of each other, but they are interconnected, and that's the requirement for the whole application to work. Right now, the front end is running, but the back end is not, so that's why we're seeing this error. So what I'm going to do is run all my back end services. Now, I'm using Docker containers and Docker Compose to run all of the back end services. Let me go ahead and do that. It's going to be Docker Compose up. So the reason I'm using Docker Compose, and I could have gone the route of Kubernetes, but I decided to skip Kubernetes because I'd have to upload the images, and then anytime I wanted to make a change, I'd have to go through the whole shebang of update the image, pull the image, and then also there's Kubernetes YAML, yada yada yada. All I'm trying to say is Docker is easy, and it just works in my case right now, just for a local development context. So here's my Docker Compose file with all the different services, and I'll show one example of a Docker file. They're basically the same. So this is one, and listener service. It's all the same, the Docker file. So that's my little spiel for why I'm using Docker Compose. So now that I have my Docker Compose up and running, if I redo this test broker, it should work. There we go. We get a response from the broker service. So here we can see, we got the error equals false, which means no error. And then, there's that response. Now I'm going to hit this other backend service, the authentication service. And let's see. So yeah, we got another success. When I hit this test auth, what it does is it sends a JSON payload, which has these email and password, email and password fields. And then we receive this back like a little response, like who is this person, the ID, and all that good stuff. So here's something I want to point out in this case. So first of all, you can see it's a response from the broker service, like the first one. So when I do test auth, we get a response from the broker service. So with a microservice architecture, what's like happening here, at least in this case, is like I have my front end, right? My front end is connecting to a backend service, in this case, the broker service. So I'm going to do that and a little bit larger. All right, so my front end is connecting to the, wait, I didn't mean to do that. My front end is connecting to the broker service. And when I wanted to do an authentication, it again goes to the broker service, and the broker service determines where to send that request, this authentication request. In this case, what it does is it goes ahead and sends it to the authentication service. I'm just going to call it auth. And then the auth thing, gets these payload, the email and password, and then it compares it with the database that contains those user details. So it tries to match the details it gets from broker and then match it with the data that's in a Postgres database. So if it matches, then we're going to get a success. The thing I'm trying to point out here is like the front end never directly talks to the auth service. It goes to the broker, and the broker determines where to direct that request. The broker in this case could be a Nginx server or some reverse proxy, whatever. So it could be anything. And that's just the microservice architecture way of doing things. All right, so now we have a success message. Now I do want to also fail it just to see if it will fail. And it should, so I'm just gonna try and do that. So here's my front end. I'm gonna go to my front end, which is responsible for sending this message. My front end, CMD templates, test.go, do auth. All right, so here you can see the JSON payload, which has the admin. Now I'm gonna say I'm not admin. I'm gonna save that and then reload this. So first I'm gonna hit the broker. Is it working? Yes, it is. Now I'm gonna hit the test auth. Invalid auth credentials, because this particular entry does not exist on the Postgres database. So now I'm gonna connect to the database. I'm just gonna do a new query. I hope it auto connects. It does not. By the way, I'm using Azure Data Studio. It's the best free database client for Windows, because other database clients do not have Mongo or whatever. Also, the other reason I'm using this is because like there's themes which are just the same themes like VS Code. I do like this one, I'll be honest. All right. I'm gonna do a select star from users. All right. So here we can see, the database has admin@example.com and not admin. So that's why this thing failed. So yeah, that's a simple authentication example. Or in this case, the example of multiple services talking to each other. And in this case, the auth service failed to, validate this request. All right, so moving on. So this is going to be the flow for this demo, which is like, I'll hit one of these, things and then explain what it does on the back end. So now auth is done. Now let's do test log. So test log, what it does is like it just logs an entry onto another database through the logging service. So here there's this logging service. This thing, it's called logger service, but like, yeah, that's the thing. It just does logging. So here's another thing to notice here is like it says logged via RabbitMQ. Now RabbitMQ, it's built on the platform of AMQP, which is Advanced Message Queuing Protocol. There's that thing. So basically RabbitMQ is really good for, it's fast. So it helps with decoupling some of these, services. So let me go ahead and do the diagram real quick. So I'm going to do, what is it? RabbitMQ. And then also it does connect to the log service. All right, let's just call it logging. So instead of the broker directly connecting to, I didn't mean to do that. Instead of the broker directly connecting to logging, now it goes ahead and pushes the logging request, the log payload, which is this one. So it, puts that log payload onto RabbitMQ, and MQ, that letter Q is for queue. So there's a little queue where it has this thing, and then it's gonna emit that or like push forward that JSON or whatever to the logging service. And then the logging service also has another database where it's going to store those logs. In this case, it's a MongoDB. Right, so I'm just gonna do the arrows. All right, I'm gonna just make it a little bit nicer. So RabbitMQ. Because of RabbitMQ now, if the broker had to talk to logging directly and then the logging for some reason, let's say it's not working, then the broker is stuck on, having to wait for a response here. So for that reason, RabbitMQ is pretty good, and it's used in microservice architecture. It's fast and it decouples some of these, interconnected services. So that's a little bit about, RabbitMQ. Now I'm just going to do the thing with continuing. So I'm just going to continue with testing mail. So here's a simple mail service. You know what? I'm not going to go into too much detail. I'm going to go into gRPC. Now, before I get into gRPC, let me also show the MongoDB database. So I'm just going to double click connect. If I go into logs, now there should be a couple of logs in here. So I'm just going to do view documents. That's the Mongo way of doing things. So here's a whole bunch of data. I'm just going to go ahead and clear all of these. So, all right, sometimes, sometimes things happen. So I think I know what's happening here. I've got to go to my front end test here. So I had to do a little git reset, and then I guess I forgot to change the thing in here. What is it going to be? It's going to be delete. Yeah. So this was the thing I had to change. All right. So now I'm going to have to rerun my thing. And then a refresh, and then clear Mongo. Okay, right. This is something I forgot to do. So now if I go back to my MongoDB here, there should be no documents. There we go. Cool. So now what I'm going to do is test the gRPC. If I do gRPC, and let me do a whole bunch of times. And then if I refresh, it should have all those gRPC log events, some gRPC data for log. Right. gRPC, it's the fastest communication protocol, and it's mainly used in backend services because it works with buffers instead of JSONs or CSVs or whatever. So buffers, binary data, it's faster, developed by Google. Sounds like I'm doing an advert for gRPC, even though it's just a technology that it's agnostic and all that good stuff. All right. So let me go ahead and explain or show the proto file, which contains the definition for the gRPC. So it's pretty simple. It's once again, it's just logging. Here you can see on position 1, it has the name of the thing. Data is on position 2, which in this case is just this thing. And yeah, it's pretty simple. I guess I can show the write log implementation. By the way, this is also a very simple gRPC example. It's a unary gRPC. It's just a request and response. All right. I'm going to go ahead and show the write log thing, which should be here. All right, here's the write log implementation. Again, it's pretty simple. It just connects to the gRPC server and then just goes ahead and inserts onto the Mongo, which is part of the whole models thing, or like the implementation. I don't know. I feel like I'm just yapping random stuff, but basically the end result of this is like gRPC is fast, and in this case, it's just logging. So yeah, that's a simple, I hope, pretty simple example of a microservice architecture, where all these things are running on the background on their own. Wait, let me pull up this diagram, right? All these little apps which are independent and just running on their own, and then the front end, initiates something, and then whatever that something is, it gets routed to the right service, and that's how the app works. Yeah, just wanted to keep it simple. Thanks for watching.